Today we're going to be talking about estimating area under a curve by using what we call a Riemann sum, and that's using a bunch of rectangles. Now this first example is just kind of an introductory example of what we're going to be doing basically the rest of the semester. So a train moves along a track at a steady rate of 75 miles per hour from 7 to 9 a.m. I need to know the total distance traveled by our train. So from previous math courses, we know distance is rate times time. So to figure out our total distance, we multiply our rate times the time, which is 2 hours, to get 150 miles. But now looking at this in terms of calculus and looking at it in terms of area under the curve, we have our velocity curve, which is a straight line of 75, and we have the time graph from 7 to 9. Now how would I find the area of this blue region? Well, our height is 75, our width is 2. So to get our area, we multiply 75 times 2, which is 150 miles. So notice how when I found area under the curve of a velocity function, that got us our distance. Well, we know the derivative of position is velocity. What we're going to be doing is we're going to be going backwards, and we're going to be taking what we call the integral, and that's the integral sign. So when I take the integral of position of the velocity curve, I'm going to get back position. So our position is equal to the integral of velocity. And don't worry if you don't understand what an integral is yet. That's why we're going to grow. And that's what we're going to really be defining in this chapter. Okay, first we're going to start estimating area under the curve by what we call Riemann sums, or Riemann rectangles. So using rectangles to determine area under the curve. So each one is going to have a certain width, and each one's going to have a unique height to it. Notice how the heights are different for them. The area above the x-axis is positive, so all of this area, when I'm estimating, is positive. Area below the x-axis is going to be considered negative. There are three types of Riemann sums. We can use a left side, or our book calls this LRAM, left Riemann approximation, okay, where you break up your different heights, okay, and you figure out your height by looking at the leftmost endpoint of each one of your intervals. So the left endpoint for each one of the intervals, and the left endpoint for each one of the intervals until you get to the very end. And a lot of times we're going to be going from A to B. Right endpoint is once you've figured out what the height is, or what you figured out what the width is, you go to the right endpoint of that height interval to get your height for your function values. And notice how some rectangles are going to be outside, parts are going to be outside, but that's going to compensate for this piece that was underneath there. And then, just as a reminder, our book, I believe, calls this RRAM. And then the middle one, where you look at your interval and you find the midpoint, and that's going to determine what your height is. Middle determines your height. The middle determines the height. And this is, I think they call this MRAM. Okay, so let's go through an example. Estimate the area under the curve using 3 equal subintervals with a midpoint approximation. Well, our A is 0, our B is 6. So you do B divided by A over N, where N is our number of rectangles. So I have to figure out what this is my delta X, or what we think of as the width of each one of our rectangles. So we have 6 minus 0. I need it in 3. So our width is going to be 2. So that's going to be 1, that's going to be 1, and I'm going to have 1 there. Now, I have a hint, draw in the rectangles. It makes sense to you guys if you draw in the rectangles, okay, to figure out what the height is, because the delta x is our width. Now you need to figure out the height. That's going to be a function value. So what you have to do is if we're using midpoint, you go halfway in between 0 and 2, which is 1, go up, find that function value. This is one rectangle that you're going to have. And we're going to find the area of that rectangle. Another one, the midpoint between 2 and 4 is 3. You go up to that function value, and this is your second one, your second rectangle that we're going to be finding the area of. And then our third one, you go halfway in between 4 and 6, you go up here, that's going to be our last rectangle that we're going to find the area of. Okay, so let's look at what each one of our rectangles are. The width is going to be 2. The height is this function value. That's our function value evaluated at 1. So that's going to be 2 times, when I plug in 1 there, we end up getting 5. So the area of that rectangle is equal to 10. Now the next rectangle, okay, my width is 2. Our height, this is our height. The height is the function evaluated at where I found my height, which was f of 3. When I plug in 3, I get 9, so that's 2 times 9, which is 18. So the area of that rectangle is 18. Now, we're going to find the area of this rectangle. My width is 2. My height is this function value. That's going to be f of, we were looking between 4 and 6, so that's 5. When I plug in 5, I get 5 out, so I have 2 times 5, that's going to be 10. So what's my area approximation? Remember, this is just an approximation because we have a little bit over, and I'm not compensating for this. We add those together to get 38. Okay, next. A particle starts at x equals 0 and moves along the x-axis, and it gives us this velocity function for t greater than or equal to 0. Where's the particle at t equals 2? So where is it? Which means, what's my distance that I've traveled? Estimate the area using 4 rectangles of equal lengths and heights determined by left endpoint. So I'm finding the area under the curve. So that I have an idea of what my area under the curve is, I'm going to look at let me find what each width is, what each width of my rectangle is. Okay, so I'm going from 2 to 0. So this is my B and that's my A. And then remember I take and I divide that by n, the number of rectangles. So they want 4 rectangles. So my width is going to be 1/2. So what I'm going to do is I'm going to make that be 1/2, that be 1, this be 3/2, 1.5, and let this be 2. Okay. And I'm just going to go by 1s on my y-axis. So I'm going to find an idea of what each one of the function values are. When I plug in 1, I'm going to get 3. So I know I start at 2. When I plug in 1, I'm going to get 3. When I plug in 2, we're going to get 6. So that's 3, 4, 6. So this is an idea, and it's a parabola. So that's an idea of what our curve looks like. Now let's look at what our rectangles look like. Okay, and I encourage you to draw in your rectangles. It's easier for you guys to see if you draw in the rectangles. I'm using left endpoint, which means one rectangle is going to start here because on my interval that's to the left. You draw up and over. That's rectangle 1. Okay? Rectangle 2, left endpoint. So between 1/2 and 1, you go to the left, up, and over. That's going to be the second rectangle we find the area of. The next one, go to the between 1 and 3/2, you go to the left endpoint, go up. There's your next rectangle that we're going to find the area of. And then the last one I'll draw in red. Between 3/2 and 2, the left endpoint, you go up to figure out what your height is, and over, draw in your rectangle. So now it's just a matter of finding the area of each one of those. The width for each one is 1/2. Now the height for each one is different. But remember, the height is going to be the function value. So this is f of 0. For the next one, it's f of 1/2. For the next one, it's f of 1. For the next one, it's f of 3/2. Okay? So when you add all of these together, basically you have 1/2 f of 0 plus f of 1/2 plus f of 1 plus f of 3/2. So that's a shorter way that you can do this, and that's going to mean something to us. When we add all of those together, we get 23/4. Okay, the next example. Estimate the area under the curve using 4 rectangles of equal widths by a right endpoint. And I did one of each one of these types for you guys. So let's figure out what our delta x, or our width, is. That's b minus a, so 4 minus 0. I need 4 rectangles, so each of the widths is 1. X cubed plus 1. A cubic curve that looks something like that. So each one of my, so that's each one of my intervals. I'm doing a right endpoint. So on your interval, you go to the right side of it, and this looks like it's going to overestimate. Go to the right side of each one of the intervals. Overestimates. Right side, and right side again, and these are all equal, it's just how I drew them. So each one of these rectangles, we're going to find the area of. Well, the delta x is the same for each one, and it's 1, so I'm just going to pull that out in front, and let's add together all of our function values. This was the height of the first rectangle, so that's going to be f of 1. Because this was 1, 2, 3, and 4. The next one was f of 2. Next one, f of 3. Next one was f of 4. So notice how I didn't include 0 because it wasn't the left endpoint, it was right endpoint. So I started over a little bit to get my height. When I add all those together, we get 104. Okay, using a calculator and sum in sequence. Okay, your calculator is going to be super helpful sometimes in helping you guys find these. Okay, so remember, area, it was the length times the height, where our height a lot of times was a function value, and the length we called delta x. And we found delta x by doing b over a. The height of each one of the rectangles is really a sum of a sequence. If you think about it, each one of these is a sequence. Okay, it's adding together a bunch of integral terms where this is the function that we're trying to find the sum of. Okay, so this is the syntax you're going to write in your calculator. Make sure that when you type this in your calculator, you also multiply by delta x, and I'll go through an example of that. Okay, so for left endpoint, we start, if it makes sense, at f of a. We end, the length for each one is delta x, or b minus a over n. We end with a left endpoint. You take your b and you subtract whatever your height was. For right endpoint, we ended at f of b, and what we did is we took f of a, we started by adding in our delta x. We went over to the right side of our interval and added. Now the midpoint, for midpoint, we started at a, but we went over half of our delta x to get that value. And then we ended 1/2 less than b. Okay, so let's go through an example of this. Okay, estimate the area under the curve using 10 equal subintervals using right, left, and midpoint approximation on our interval from 1 to 4. Okay, so delta x is 4 minus 1 over 10, or 3/10. So, in your calculator, for the right interval, make sure you remember that this 3/10 is your height. So 3/10, and that it's your height, it's your width. Now, in our calculator, we have to calculate the sum sequence. I'm going from 1 to 4. So for right endpoint, you go to the right of your interval and draw your rectangle up. So your first function value is, so I'm doing a sum of a sequence. Now you plug in your function. You have to tell it the variable. Now this first number is the first number that you put in. So that's 1 3/10. Okay, that's the first one. This is the first one I want to find my function value for. Now for right endpoint, remember, we add all the way to 4. So my ending number is 4. And that's what we would type in our calculator. And when you type that in your calculator, and I'll go through this, I'll show you guys, I'll pull up my calculator here in a minute. When I type this in my calculator, I should get to 2 decimal places, 2.562. Now for left endpoint. Okay, we're still talking about that same interval. We're still talking about from 1 to 4, but now I start out my left endpoint drawing my rectangles. Left endpoint drawing my rectangles. Okay, so for the left, you have this same height, 3/10. I keep saying height. That's your width. 3/10 is your width. This other piece now, this is my height. My height is the sum of a sequence of a bunch of numbers. Again, you type in the function. You type in your variable x. Where did I start? The first function value I want to add together is 1. The last one, your last rectangle, is going to be 4 minus 3/10. So that's going to be 37/10. I apologize, I forgot to put in here. You have to tell it what interval you want to go up by, so that's 3/10. So actually up here, I should have something else in there. I need to tell it the interval, which is 3/10. So when I type that in my calculator, I get 3.012. 2. Now midpoint. Again, for each one of these, the height is the same. We're doing a sum of a sequence of a function. Then we have our x. Now for midpoint, you take half of your delta x, which is 3/20ths, and you add that to 1. So that's 23/20ths. And then you end your interval halfway in between, so a little bit less, halfway less than b, which is 77/20ths. And then remember to type in what you need to tell the calculator what you want to go up by. And when I type this in to my calculator, I get 2.766. So let me show you guys this now, typing this in your calculator, because you're going to have to know where to get the sum in the sequence. Now realize your calculator might look slightly different than mine. So I'll help you guys in class if your calculator looks different than mine. Okay, to find the sum of the sequence in your calculator, remember you have to tell it what the height is. So 3 divided by 10 times by. Now the sum of the sequence, I'm going to do the right endpoint first, which is what we had. So sum is second list. And if you arrow over all the way to math, you want to do the sum, so that's number 5, of a sequence. And it's under that same second stat, which brings you over to list, operations, sequence. The sum of the sequence. Now you need to type in the function, 2 divided by x, comma. That's when you use the comma. You need to tell it the variable, which is x. You need to tell it the beginning number, which was 13/10. You need to tell it the end number, which was 4. Then you need to tell it the increment you want it to go up by. It's going to assume you go up by an integer unless you type in a number here. Remember, our interval was 3/10. So 3 divided by 10. Press enter. And 2.562, that's what we came up with. Okay, and you're going to do the same thing for the left endpoint and the right endpoint. I'm just not going to type this in because the video is getting kind of long. So that's how you do one of them. And I want you guys to try those left and middle on your own. And remind me in class to show you guys, if you guys have a different type of calculator, how to do this sum sequence. Because some of you guys are going to have an easier way to type all this stuff in. So please make sure your lesson video summary is submitted on time.